Okay, if randomly anybody's watching this, I'm doing a school presentation right now. I cannot stream it to my other account, so it's on this YouTube channel. I'm deleting this later, so click off, okay? Cool. Alrighty. Or you can watch it just for the memes. Alrighty. We're learning about plutonium and why it's dangerous in water. So, cool. Hello, I'm Tristan Blenner-Hassett, and today we're doing the chemistry final project. Hidden Without a Trace, What is Underwater by Tristan Blenner-Hassett. Plutonium, what is it? The basics of plutonium. The element name is plutonium. Element symbol is Pu. Atomic number is 94. Atomic mass is 244 U. The number of protons is 94. Number of neutrons is 150. And the number of electrons per shell is 2, 8, 18, 32, 24, 8, and 2 valence electrons. The total is 94. Plutonium has 5 isotopes: Pu-238, Pu-239, Pu-240, Pu-241, and Pu-242. Plutonium, a brief history. Where is it from? So the origins of the name plutonium come from the planet Pluto, which is actually following a trend with uranium, and neptunium, which is uranium's from Uranus, or Uranus, however you'd like to pronounce it, and neptunium is from Neptune. Who and when? Plutonium was actually discovered by Glenn Seaborg and his colleagues in the year 1940. This element was actually discovered in California. Here is the plutonium Bohr model. We have the standard one on the left, which shows Pu in the middle, and each electron on the outside. There is 2 valence electrons, which are on the 7th shell, the outermost. And the one on the right is a similar model, except it shows the number of protons and the neutrons in the middle, and it has more of a cloud-shaped shell system. Plutonium location. Plutonium is located in the bottom separated part of the periodic table. Not every periodic table has a bottom section. Sometimes it's connected, but it is in group 8 at the very bottom. Plutonium is in the actinides family. Atoms that have a greater number than uranium's 92 are called beyond uranium atoms, and they are very powerful. Plutonium properties and characteristics. Physical characteristics: it is a very silvery appearance and is very shiny. However, when it is oxidized, it's very yellow. It's a super chemically reactive element. A large chunk of plutonium is actually really warm to the touch because of the energy given off in its alpha particle decay. Its density is 19.84 grams centimeters cubed to the negative cubed. Melting point is 1,183 degrees Fahrenheit. Boiling point is 5,849 degrees Fahrenheit. And it's really reactive with air, hydrochloric, hydrioric, and perchloric acids, as well as the halogens carbon, nitrogen, and silicon. Real-world applications for plutonium. Plutonium is mainly used for creating nuclear weapons and powering nuclear power plants. Plutonium is really powerful and contains a lot of energy, which is highly reactive, and humans have taken advantage of this by making it into a power source or extremely powerful weapons such as a nuke. Plutonium claim, evidence, reasoning: why it should or shouldn't be in our water. Claim: plutonium should not be allowed to be in the New York's water supply. There was a case where plutonium in a large amount was found in the New York's water supply, and we'll get into that in a second. Evidence: according to the New York Times, a small level of plutonium was found in the New York water supply. This took place on July 27th, 1985. Someone actually threatened to add more plutonium into the water supply. This is just another point that proves plutonium is extremely dangerous, because if it wasn't, no one would ever threaten to put it in an entire water supply, because plutonium is extremely harmful to the human body. The amount of plutonium was abnormal. It was way above the normal amount, which is usually 0 or a very small amount. However, at the time, it was well below the safety danger level. So even though it wasn't a large amount in this situation, it is still extremely dangerous and should not be consumed on any level whatsoever. The threat threatened to put more plutonium in the water supply, shows that it's a very dangerous subject. We've already went over this. And according to the CDC, plutonium emits alpha particles, which are the most dangerous when inhaled or consumed. So this would be an example of consumption if it was in the water supply, because if you drink water with plutonium in it, you are actually inhaling its alpha particles as well. And alpha particles can damage lung cells, and if it gets into the bloodstream, it can destroy many vital organs, just as the kidneys and liver. These are all extremely important organs. You can lose maybe one kidney and be okay, but this will damage both your kidneys at the same time. And to a point, it can even destroy your bones, which obviously is very important because your skeleton and all your organs are very important to your survival. And reasoning. Plutonium has no place in any water supply because of the dangers that come along with it. Plutonium is one of the most damaging elements and is extremely reactive and radioactive. It emits alpha particles, which can be fatal to humans and other organisms. So this includes plants, dogs, other animals, and humans, pets as well. Alpha particles, if inhaled or consumed, will damage many organs, including the lungs, liver, and kidneys, which are all very important to a person's survival. They damage many other organs too, but these are just the main ones that it directly damages. This will also severely affect your immune system and cardiovascular system if your liver and kidneys are down. And another point to touch on is that plutonium is very explosive and reactive, and if enough plutonium ends up in one place and comes in contact with the material it reacts with, it can potentially lead to an disaster. So for some reason, some kind of hydrochloric acid or something mixes in with the water or pipes, it can potentially cause an explosion of some sort, which is extremely dangerous. Thank you for listening to this presentation, and here are my works cited. Here's the general information for plutonium for the first part of the presentation and the second part of the presentation. Thank you for watching, and have a great rest of your night.